Before we start, I want to talk about well, my ex. I'm not going to talk about my ex. I talked. Never mind, I'm not going to talk about it. I want to talk about this project impact every one of us, including Jan, that is very stubborn. And how and how the software impacts every sector and people. We really care about this. Personally, me and I think everyone. So I think it's I hope we will present this in our presentation.
Okay. Well, first of all, who are we? Who are we that are going to present this? Carlos, Tío, Luis Gutiérrez, Sebastián Rico, Santiago Villan, and myself. And let's begin with the good stuff. Okay, well, first of all, the situation or the background for why we decided to do this is because epilepsy is it's a chronic brain disease that affects almost around 50 million of people worldwide and has a death rate of 50,000 people per year. So this disease is the most common and is prevalent on children and the elderly, affecting not just the patient and also the caregivers. While we have no specific data for Mexico, we have that in countries like the US, they have for all the emergency cases, 1%, let's say 1.2 million of cases of emergency are related to seizures. This is because the epilepsy can have status epilepticus, that is when a seizure lasts more than 5 minutes, and epilepsy can lead to sudden. What is sudden? Is sudden, unexpected death on epilepsy. And it happens because of the incidents related to seizures and the status epilepticus. And it is a proportion of 1 to 150 on each individual that suffer from epilepsy. In Mexico, just in Mexico, we have 2 million people with epilepsy and a range of 20 to 30% of people that suffer tonic-clonic. That is our target seizure attack for this project. In low to middle income countries, epilepsy is more prevalent and it has more difficulties to access of the medicine, and they have that 16 to 20% of the death or attacks of the death of the sudden are preventable. So we aim to reduce that percentage because the most common is that 30% is go unnoticed and this causes incidents and more.
Well, what are our objectives? We want to detect at least. Well, we want to detect 90% of seizures within the first 3 years. When in Mexico, we have we're going to capture at least 10% within 5 years with the first year of launch, and an 8% in frequent consultation, reduce the 8% in frequent consultation with patients.
I wake up every day with fear, not of epilepsy, but rather of being without help when I need it. A shared thought by millions of people that live with this situation. People with epilepsy live with the constant uncertainty of that a seizure can happen at any time, making them vulnerable to injury, accidents, or in some cases, fatal results. So, and this situation can be even worse because they are not conscious and they cannot communicate with family, caregivers, or emergency services. So, could you imagine living with this uncertainty of that your life could be in danger at any time and no one will know. That's why the epilepsy system is here.
Alright, so what is the current situation with this? Well, right now we have that the best case scenario of our problem is that if the patient have an attack or a seizure, then the caregiver is nearby. If the caregiver is nearby, okay, everything goes good, it will be treated the right way. But if not, there could be certain other cases that could happen. The other one is that a stranger is nearby. So here there could be another fluctuation that a stranger gives the help or not. If the stranger gives the help, okay, he can contact the caregiver, of course, if he has the phone or any other communication. Like, well, the caregiver can come to treat the patient. But if not, the patient is going untreated in an incorrect way.
Well, now this diagram highlights the difficulty of manually tracking seizures. This is because often the patients miss details.
Okay, this diagram represents when a doctor has to track the seizures of a patient, and the seizure already happened, and the patient goes to the doctor, and now the doctor needs to track the seizures to give a better treatment. But what happens? The doctor asks the patient to keep track, but if the patient doesn't have a caregiver that keep tracks for him the seizures and he's alone, or the caregiver can track the seizures, then the patient goes to the difficulty that he is going to be unconscious or probably in the floor having a convulsion. So he's not going to be able to record the time or or how many seizures he has at the day, because most of the time they lose also the memory of the seizure. So what happens? The doctor doesn't have good information for a good treatment, doesn't have the data of the EDA, electrodermal activity, or vital signs to make a better treatment. This treatment can go and last more years than they should, and that's it.
Well, as I was saying, patients often miss details. This is because they maybe are alone or are unconscious. And yeah, the caregivers may witness the seizures, but they only provide subjective and incomplete notes. This causing the doctor to have lack of critical information, such as duration, frequency, and vital signs.
Okay, this is the context model of how our system is going to interact with the people of our domain. We have that the system is going to interact with the devices that already the patient has. So it's going to need to be capable of working with Android or iOS. And in the case of the healthcare providers, devices, you need to be able to work with any explorer like Google Chrome or Firefox or Explorer. And it's going to use Bluetooth because it's going to be a wearable in a part, and then it's going to have the software that is the one that is going to be in the explorers. And also, this is going to send alerts, and these alerts are going to be received and sent with JSON and MQTT.
Well, now our solution. Our solution is to a wearable device that can monitorize the patient's vital signs data, and the patient can monitorize between the app and the wearable device, and the doctor can access by the computer. This is because the doctor mainly uses the computer to work. And imagine you're a parent of a child that has epilepsy, and you can leave the child alone, like playing, while the device is monitoring the children to to not have a seizure, and you can rest like as you need, like leaving the child alone.
Well, so we did a depth-in investigation with Dr. Jose, and we identified the key parameters to detect the seizures. And we are using these device components in order to track and detect the seizures. The heart rate, the accelerometer, the gyroscope, the EDA, that is the electrodermal activity, and the time.
Okay, the stakeholders are, or direct users are the healthcare professional, the patient, and the caregivers. The indirect users, the advocate groups, sponsors, the doctor, as previously mentioned, and the rule makers, obviously, the Secretary of Health and Privacy Regulatories.
All right, so in which domain are we are going to operate? Well, first of all, of course, we have a system. This is, of course, our software and wearable device. This is the one that's going to alert the caregiver in case of a seizure because it's continuously monitoring the patient. And the patient has many other extensions, like he has a medical report, of course, a seizure event, like this one suffer at any time, or a disease, in this case, part of the medical record. And the thing to notice here is that we are going to alert the caregiver, not the physician or the doctor, because the doctor can have many patients, so it will be easy.
Well, now we are going to present the architecture. We choose multi-tier. And the first tier is presentation. This is like the visual. The things that the user can see as text, images, and it displays the data to users, and it collects the user information as the name, the password, and the mail.
And then we have the other tier that is device, and here is where all the sensors and parameters will work in order to detect seizures. Also, with other responsibilities to a local processment of the data in order to send alerts. And the last responsibility is to communicate with the logical tier in order to store all the data.
For the integration tier, serves as a bridge between the wearable device and the logic tier. Basically, what it does is communicates using the API gateway and translate to the integration, with the HTTP or CPS or whatever it may be, and ensure the secure and reliable data transfer.
Well, now the logic. This one is connected with the presentation one, and it collects all the, well, receives all the user data that the presentation collects. Then it follows some rules, like maybe if the password was wrong or it's not the password that is like keeps it. And its work is to authenticate, validate, and decision making.
The data will basically is stored, retrieving, and managing, which means managing the databases, creating, deleting, updating everything, and obviously the secure, being secure.
Okay, so now here we have our company diagram. Next, we're going to explain this more detail with our prototype. But of course, we have the presentation tier, the visual. We have the request, the parser, the profile manager. We need to, of course, manage many profiles or 3 types, and to be more specific, the doctor, the caregiver, and the patient. And we have the contact. The patient is going to be allowed to add some contacts in order to communicate when the seizure occurs, to notify them. And the treatment view, the medication, diet, and the appointments, all of that. And then we have the alert display. The alert display will be, of course, notifications and be a record of all these alerts that have happened. The data visualizer in real time, and the monitoring dashboard. We have the device tier with sensors, and the integration tier with authentication and data.
And for the logic tier, we have the receiver, response dispatcher, monitoring module, and notification service. in the data tier, we have some entities to store all the relevant data for our system, that is patient, seizure, treatment, contacts, and notifications.
Okay, here are the non-functional requirements. First of all, we need performance, and it has to have a response time of 250 to 400 milliseconds, because we need information on almost real time, and it has to process the data in less than 500 milliseconds. The security, we're going to use TLS, transport layer security for the communication, and AES 256 for the encryption of the data, and assure that no one without the access can, without the verified access, can access to the system. Integrity, it's about the integrity of the data, so we need to perform automatically integrity checks every 5 minutes so the data is correct. And we will retain logs for 2 years with timestamp accuracy. Reliability, the device needs to be reliable to be used at any moment, at any time. So you can use it underwater, at least 10 meters. It will be able to be used in 15 minus degrees and 35 degrees above. Scalability, we will start with a target of 50,000, and usability, it has to be able to be used at least 2 days straight.
So now
we go to the
we are going to present our prototype. Of course, we have the login screen. This is the developing footer, and then we can create some accounts. These accounts, of course, we have to fill all of those charts or sets. And we can select the account type. Of course, we have 3, and we have to set the terms and conditions. But we have set some accounts now. We have 3 accounts, so we are going to start with the first one. So this is the patient one. In the first one, we have the live vital signs. Of course, this was a simulation. Our skills didn't achieve to make the physical device or the wearable, but this is a simulation about what it should be live vital signs with the heart rate, the CSL, and the CSR. This is part of the data, how it's divided. One is for the electrodermal activity in more longer period of time, and the right one, this one, is for in shorter time. Then we have the seizure history. Of course, we have here some seizures, and we can click on them, like we have the date, and we can see all the information of the seizure, like date, the duration, the strength, the heart rate, of course, the accelerometer, the velocity, and the gyroscope. And we can request the location of where it was set, like simulation of it. And we have the current treatment, and we have the medication, diet, and step guidelines. So we have medication, the type of medicine with the amount, the diet, the sleep guidelines, and therapy. And a part of our features is that you can view its own profile. This is part of the profile, and it can be updated or deleted. So after that, we have the caregivers. Here's where the patient adds the caregiver's contact, the information and numbers. We have 3 right now, but we can add more. And next to that, we have the one of the caregiver that is like the mother. Here is like the simulation of our alert that is happening right now, the current information of the current alert, and of course we can use the location in order to attend to the patient to be treated. In this part is almost the same information, but where it's different here is that we have the alert history, since the caregiver is the only one who is going to receive alerts. And finally, we have the doctor one. The doctor one have patients, many patients. We have 2 here that we can see all the information of each patient, the history of seizures, and the treatment. Something to notice here is that the doctor can edit this medication to change in order to improve the treatment or configure it in a different way. And after that, we have the assignment or the appointments in order for a future, in order to treat these patients in a specific date. This can be, of course, seen. And finally, the thresholds. The thresholds for each patient are important too, to send the alerts.
Very simple one. Being a wearable, how can you think it can be made scalable?
Please.
As the project is basically a wearable with the software, but a wearable, how can you think you can make it scalable? Scalability.
Well, the system is not just the wearable, the tiers, the tiers includes the database server and the applications, the software. So the thing that we aim to be scalable, the thing that we aim to the scalability is that we can afford to have 50,000 and then more people. That 50,000 is our main target because it's the 10% of the. It was in the objectives. We have the 50,000 people of the main target of first, and the scalability is for then could have more users at the same time, because this is something that it needs to be everyone at the same time.
It's a 10% in Mexico, but meant the world, I mean, that's the scalability. People with epilepsy, that's a lot of people.
Yes, also as part, the wearable is obviously a essential part of our solution, but the main idea is that the logic tier is in charge of everything, because the wearable is going to be sending all the information, and the information will be useless without the logic tier. The logic tier is in charge to process all the information and then send the alerts. That is the most important part, or to notify the caregivers.
Any other question?
Do you have any strategies in place at the moment that help maintain and update the apps architecture over time?
Yes. Can you repeat it? Yeah.
Do you have any strategies at the moment that will help you maintain and update the app's architecture over time?
I thought something.
I mean, we don't have a strictly strategy right now. The updates would be more in part of the amount of scalability, of increase the users that we need to maintain, because as we see, we have one patient, but many caregivers. So the updates will be more in the part of our database and our servers to sustain this amount of users.
Okay.
That was your question.
Yeah.
Thank you, team.